All right. Good afternoon, everyone. Welcome to my last talk of the conference, where we're going to talk about building code analyzers and code fixes using Roslyn. How many of you were in Casey's talk a couple of hours ago? Yeah, okay. How many of you have ever attempted to build a Roslyn analyzer? Okay, just a few. That's good. So we only have 45 minutes. I'm just going to do coding on stage. So it's a hit or miss. Either everything works or nothing works. So let's hope it's the first. I'm going to just walk through a very simple code analyzer and code fix that you can build that plugs in with Visual Studio. Last year I did another one over here, but I believe the sessions were at least 15 minutes longer, so I did a more ambitious one that touched on slightly more parts of the Roslyn API. So instead what I'm going to do is do a small one, and then I'll sort of highlight a couple more things as I go along about interesting parts of the API that are available. Okay, so let's get started. And so what I've done here is I've installed the latest Visual Studio, Visual Studio 2017, sorry, I'm already miscounting over there. And I also installed the Rosslyn Sdk, which actually shows up in the new project dialog over here. After you follow the steps outlined in this one, I can actually try to zoom a little bit here, maybe. It's the first time I try that. Here you go. So download the .NET Compiler Platform Sdk. It's a very boring project because it contains a single HTML file which you use to click to the download link for the plugin into Visual Studio. Once you do that, you end up with pretty much all the other things that you see over here, except for the item and project template and the v6, which are already there by default. So what you get is three things. You get support to build code refactorings, which we're not going to look at right now. You get support to build standalone code analyzer tools. Those are tools that actually can run at the command line and also that you can feed into the C# compiler and the VB compiler using the /analyzers flag. And you can also build an analyzer with code fix that gets deployed either as a NuGet or a v6 plugin to Visual Studio. Now there's one thing here that I want to point out before we proceed. It's very important to realize that analyzers, those things that bring up light bulbs in Visual Studio, telling you that something's wrong in the code or suggesting you to change the code one way or another, together with code fixes, which actually materialize those suggested changes, that these can be deployed either as plugins into Visual Studio, that's the v6 side of the house, but they can also come inside the NuGet package. And so what you see is that a lot of libraries, a good example being XUnit, which is a unit testing framework, ships with analyzers. So when you use that, you get actually new light bulbs, which are domain specific, that actually encode the best practices of that library. So in case you build a library and you want certain rules to go with that for users of that library, you can also deploy those guys using NuGet. And so I'm going to actually focus on creating an analyzer with code fix in this project. So let me get back over here to minimize that. So I'm going to create an analyzer with code fix. And let me actually put that in the temp folder over here. And I'm going to call it name of fix. It's a very simple one, but it will sort of highlight the basics of the API. So we're just going to create this thing. I will actually get a solution with three projects here. The first project will contain the bulk of the code. That will be the code analyzer as well as the code fix provider. It's actually adding a bunch of NuGet packages here, and it's taking it because I'm using the Wi-Fi here, so it will take a moment. And then we have a couple of other things here. So let me try to zoom in one more time so you can actually see what I got here, and then we'll just start focusing on the details. So we'll do all of our stuff in the first thing here, which is a portable library called name of fix. That's the name I gave it. And we have two things in here. We have the analyzer. Think of it as follows. The analyzer is the thing that will look at the code that the user writes and will actually make suggestions. After evaluating a certain set of conditions, it will bring up the light bulb. And that light bulb will sit somewhere in the code so the user can see that something gets squiggled or whatever, and you will actually see the diagnostic appearing. Also in the output window, if you use it at the command line, you will see it in the output of the compiler. The second thing here is the code fix provider. And the way to think about a code fix provider is that it gets invoked when the user clicks on the light bulb. And then the code fix provider will take the current state of the code, will create a suggested new version of the code, and that enables the UI in Visual Studio to bring up the red lines and the green lines showing we're going to take this out, we're going to insert this instead. The user can then click yes, I want this, or no, I don't want that. And in case you say yes, I want this, the result gets persisted. So that's pretty much the interaction between the two. There's also some unit tests over here. I'm not going to focus too much on these today. And then at the bottom over here, you have the v6, which is the thing that will be used to get this thing installed into Visual Studio. But you see it also has a new spec file here. So this first thing could also be picked up as a NuGet package and sort of be deployed together with your application. So it's a zero install situation. You don't have to edit the Visual Studio configuration. It just comes in as part of a library. Okay, so that's what we have here. So now let's actually focus on the code itself. So I'm going to boost the font size here a little bit. And so what we're going to build is the equivalent of this light bulb. So we're going to get this kind of experience, not for taking away unnecessary usings, but what I want to build here is something that will suggest to use nameOf in C#6 in case you use a regular string literal to refer to, say, a parameter name in a method. Very simple thing to actually do. Now, what we get here by default is a little example, and I'm just going to run that example by hitting F5 here, so you get some familiarity with the way that you actually build these things. You will just hit F5, and what's happening now is that we actually launch another instance of Visual Studio in the so-called experimental hive. So all the settings of that Visual Studio instance are isolated from your main Visual Studio, and that's actually one that will load this plugin in there. So we'll install this plugin into that Visual Studio instance, and what you will see happen next is that as I do something here in the editor in C# or VB, depending on the code analyzer I'm writing, we will actually hit breakpoints on the other side. So what I'm doing here is I'm really debugging an instance of Visual Studio that hosts my code analyzer and my code fix provider by actually using the debugger that's attached across Visual Studio instances. So what's happening now is you see something called writing component cache. That's actually where this this code analyzer and code fix get injected into the other Visual Studio instance. VS actually discovers those guys using MEF, the Managed Extensibility Framework. So that's the update that happened over there. And so you see over here, what I actually want to build is something that will ultimately bring up some light bulb over here to tell me that this string s that I have sitting here, it would be better to actually do it using nameOf instead of just having a string literal. And ultimately, if we have time, I want to do it over here for a lambda expression as well. Now, the default analyzer that I get here is actually the one that you see lit up over here. This is the sample analyzer. So when you create, this default analyzer, you end up with this. And so what it does is it actually suggests you to make this thing all uppercase. This is complete nonsense, that's just the example, but that's what you get when you do F5 without changing anything to the default templates, okay? And I'll show you the code behind that one. Now I just noticed that there's already some light bulb over here. Okay, and that's just about, another light bulb here, which is about naming parameters explicitly using optional parameter syntax, so you actually end up, or named parameter syntax better, but that's not the one we're going to focus on. What we're going to focus on is actually seeing another light bulb here that says we're using a string literal s over here. It seems to refer to an argument or a parameter of the method you're in. Do I want to change this to nameOf? Okay, so that's just to set the context over here. I'm going to close this thing, which will cause the debugging session to finish on the other side. And so now we're going to take a look at the code that we got here. So the code that we get is, first of all, a callback to something called initialize. The way we get here is not too important. What's really happening here is that this analyzer has an attribute on top of it. It says which languages it can deal with. In this case, it's just C#, but you can also write things for VB, of course. And it inherits from some base class. The other things I'll get to in just a moment, but it all starts in initialize. And so in initialize, you actually have to convey your interests to Visual Studio and to the Rosslyn core framework. You have to say, what you want to do. And in this case, the default sample says, I would like to get a callback whenever something happens with a symbol, and a symbol is something like the identifier used for a type or a method or all of those things, and I want to be called back only for symbols that are of kind named type. So what this does is some kind of filtering that says whenever we do something with named types, we will actually do a callback here to analyze symbol. And so what you see in here is that we look at the symbol, in this case of program, for example. We check if any of the characters in the name of the symbol is a lowercase, and if that's the case, we're going to raise some diagnostic. That's actually the light bulb coming up. Now this light bulb is configured using some rule, and that rule over here by default actually picks up a bunch of strings out of a resources.resx file. So I'm just going to go to the resources.resx file over here, and what I'm going to do is I'm going to change the name here. First of all, the description of my analyzer, I'm going to say use name of, I'm just going to be a little bit blunt here, Here use name of without a dot at the end because that's the title. And here I'll say something like string literal. Then the literal will be as my parameter name. Can be changed to a name of expression, something like this, okay? So that's the string that you will see in the error window at the bottom, that you will see in the tooltip and all those kind of locations. And the rest is just, the titles that you will see also rendered in the UI in certain places. So I've just changed that now. Of course, now we have to do the real work. We have to change the code to do something more meaningful. Okay, so what I'm going to work with here is actually not symbols. When I'm talking about replacing something in a syntax tree, I have to analyze nodes. So what are nodes? Well, I'm going to go here to the View menu, Other Windows, and there's something called Syntax Visualizer. I'm just reading it out loud, and then I will zoom in over here. The Syntax Visualizer is actually something that comes with the SDK. And what it allows you to do is actually just click anywhere in the source code, and then you see the syntax tree over here. And so if you take a look at the syntax tree, this initialize thing is an identifier token. And that thing is part of a method declaration. And so as I navigate here, you actually see all of those different parts of the syntax being highlighted. This is a predefined type void. The next thing is the identifier containing initialize. We have a parameter list now, which contains an open parentheses and so forth. So what I'm doing here is kind of reverse engineering what the code looks like. And so what I want to do is obviously study over here. I'm just going to try to move a couple of things around. Like what does it look like to, for example, find that string literal that's used somewhere? So user writes something like if true, in reality it's something else, throw new, argument null, exception, something like this. Well, that's something else. That's not what I wanted. Argument null exception. I'm trusting to type correctly in this boosted world. Here we go. And so I have a string here, let's say foo. So what I want to be able to do is figure out how can I find references to this particular piece here. And it just tells me this is actually a string literal expression. So what I want to ultimately end up doing here is getting a callback for every string literal, and then I'm going to say, like, does this string literal match a parameter name that's brought in scope somehow? If that's the case, I want to raise a light bulb here. In my example before, this was argument null exception of s, where s is a parameter to the method. Okay? So let's get out of this beautiful inflated world. We studied the syntax tree a little bit. Now, how do we do this kind of coding? And you see over here another light bulb, about that code, because this thing, did control flow analysis. True is always going to be true. We're always going to throw an exception, so the rest of the code is not going to happen. Beautiful new features in VS 2017. So what I'm going to do is I'm just going to change this thing here, not to get registered for callbacks upon things pertaining name type symbols. Instead, I want to get a callback for some other reason. So I want to call back for syntax node actions. So I want to get called back to analyze nodes for certain syntax kinds. Oops, syntax kind. And that actually comes out of Microsoft.codeanalysis.c#. And here you now see a list of a whole bunch of syntax nodes that you can get called back for. But in this case, I already know what I want. I want to get a callback for example, a string literal expression. That would be one thing I could be using here to actually get back to getting a callback. Now, we could refine this a little bit more. You know, we could look at all the literals in the program. We could also specifically look for arguments that are passed to, for example, the constructor of an exception, because that's a more narrow case that I could build this analyzer for. So let's actually change this thing to arguments. So, for example, I will only get called for arguments that are passed to, say, you know, throw new argument, null exception, or something like that. This would also give me the ability to sort of assess whether the parameter means that it's actually a parameter name. So I could see like this thing gets assigned to some parameter that wants a parameter name, hence I'm going to search for parameters that are available to see if it matches a certain argument. So I'm just going to get rid of this symbol action thing. And so now I'm going to get called back over here for every time we see an argument in the code. Okay. So the next thing to do is let's actually put this thing aside. Well, it doesn't really want to go aside all that much, so let's just make it a little bit smaller. So the first thing I'm doing here is actually go to the context, which gives you all the contextual information about what's going on, and you can actually fish out the node. So the node is a syntax kind.argument. That's the kind of that node. And so I'm going to call that argument, but I want to deal with that argument in somewhat more detail. So I'm actually going to cast this thing to an argument syntax. And again, you know, I've messed up over here. I deleted some namespaces, so I just control-dotted into existence the using for C#.syntax at the top of the file. So now I can look at the argument syntax. The way you figure that out is actually by just, you know, taking a look again in the syntax visualizer, clicking on something that you want, and taking a look at the properties over there to figure out how the shape of those trees looks like. So now I have an argument. So say, for example, new argument, null exception, and then over here, I get called back for this argument, okay, for that part of the node. The next thing I want to do here now is I have an argument. What I want to check for is whether the expression of the argument is actually of a certain kind. I want to see if it's an argument that's of kind string literal. That's the thing we were just looking at a moment ago. Is this a string literal expression? So I'm actually looking for something like throw new argument exception. Doesn't matter it's throw or a new argument exception or a method call. It's for any argument that happens to be a string literal. This will not call me back for one. This will not call me back for console.readline. This will only, well, this check will only pass for this first argument, which is a string literal. So that's what I'm interested in. Okay. So if that thing is a string literal, then I can actually go to argument.expression, and I can cast this to a literal expression syntax. So now I have my literal. So it's pretty much always the same thing. You will see some kind saying it's an argument kind, then concatenate to that syntax, and then you have the node type. So in this case, string literal expression, there's a literal expression syntax. So what does that literal expression syntax look like? Well, you can actually go to that literal over here, and you can start browsing it, and you will actually find a bunch of interesting fields here. You know, you can go to the parent, you can sort of look at children. This thing doesn't happen to have a child, but you can actually go to the token and actually fish out the value text. This will be the text of that particular string. If it would be a literal of something else, like, you know, for example, an integer literal, you would be able to also get to the value of that and actually get the integer value that the user is using. So in this case, I have my identifier. Well, it's not necessarily an identifier. Let me just call it text. So that's the text that happens to be there. Now on to the next part of the fun is, of course, does this text represent something that's in scope here? That's the next question I have to answer. Is the user referring to bar in that string literal, referring or kind of wanting to refer to the name of some parameter that's in scope? So let me actually write some helper method here that will get me all the parameters that are in scope at that particular point in the code. So the way I want to achieve that is by creating some method that returns an IEnumerable of parameter syntax. How do I end up with parameter syntax? Well, let me actually show you once. You go to the syntax visualizer and you say, what's a parameter? Well, context is a parameter over here. You take a look on the right-hand side and you will see parameter. Okay, so you just start navigating here. I'm not even going to bother zoom. Well, I will actually bother zooming in once. Here you go. You see parameter syntax. That's the type used to represent the parameter. I just clicked on a parameter. I learn how the AST looks like. And this AST is huge. Like any language construct has its own kind, has its own, type. That looks very frightening at first, but with the syntax visualizer, if you know what you want to fix, type an example and start navigating to sort of learn like, oh, that's that kind, and that's that, and that's that, and so forth. So you can just explore as opposed to having to go through thousands of different node types without knowing what those things are called. Okay? So I want to get a list of all the parameters that are available. So I'll call that thing get parameters. And so the way I want to get to those parameters is by starting somewhere. And so where I'm going to start, say that you have new argument, null exception over here, right? Something like this. I want to start from this node that I have for this argument that's passed over here, and I want to start looking at the context of that thing. I want to sort of like expand out. So what I have to do is I have to walk up the chain. This bar has a parent, which will be in this case some invocation expression or something like that, or an instantiation expression for an object. This whole thing will be a statement. This whole statement will be inside a block. That block will be part of a meta declaration. Oh, and a meta declaration contains parameters. So I'm sort of, walking up the chain, all the parents, until I find a place where parameters are introduced. So I'm going to pass in over here the syntax node where I want to start from. And let me actually fill this in over here. Var parameters equals get parameters starting from, let's say, the argument. That's where, we currently are. So I want to go to all of those parameters. And let's fill in, the details in just a moment. But the next thing, after I would have all the parameters that are available, obviously the next thing I want to do here is check whether any of those parameters has a name, an identifier that refers to that text that the user put in the string literal. If that's the case, bingo, right? The user used the string in double quotes to refer to some identifier. Okay? So how to do that? We could use link here, parameters.any. Is there any parameter? And now I want to do something like this, where the parameter dot identifier dot value text equals, and I'm typing in the blind over here, where the identifier of the parameter has a text which is equal to the text that happens to be in the string literal, right? In that case, oh, we know that this is something we want the user to be fixed. Okay? Now, before we go into get parameters, where we'll do some syntax walking, I'm just going to copy paste a little bit of code and I will explain it, what that does. That's the one that brings up the light bulb, so I can get rid of the code at the bottom here, which was the sample code that came for uppercasing type names. So what's that code look like? You have that rule on top. That rule that we saw on the screen a little bit earlier is actually something that just refers to those resx files. That refers to the strings that you want to put in there, like the title of the light bulb, the format string on how to put a message on the screen. That's that thing. Now, you have one of those rules which kind of describes the shape of the diagnostic, also the ID of the diagnostic. That's used, to report that error or to do suppression using a pragma. So that's the identifier of that rule. And you have to give it two things. You have to say, like, I would like to instantiate a light bulb that looks like this, but you have to say where it has to be put. You have to sort of say the location in the code where it needs to actually light up. So that's the first thing I need to pass in here. What I'm going to do is just I'll take argument and I'll do get location. That will give me a span, or actually a location in the code that is the place where I want something to be fixed. And then secondly, you also have a params array for object arguments that fit into that format string that I created earlier. That's actually what you want to put in the concrete message, in this case saying string literal, open double quotes. The name of the string can be substituted for a name of expression. So here I'm just going to put that text that I discovered in the string literal, so it will look kind of familiar, not a stock thing. It will just say, oh, we can change the parameter name with, or the string literal containing the word person here by using name of, okay? And then I report the diagnostic. So now the get parameters thing, here I have to walk the syntax tree up until I actually find parameters. So how we're going to do that? Well, luckily there are some beautiful helper methods available to do this kind of walking for me. So I can actually say for every parent in node dot ancestors and self. That actually will return an enumerable sequence that includes myself and then all my ancestors, so I can see my parent, my grandparent, my grand-grandparent, and so forth. So now I'm looking at all the parents, and ultimately I'm going to hit a declaration of a method. Of course, I can also hit a declaration of a local function and a declaration of a lambda. I'll have to special case these things as well, but so let's just start with a method. So what does a method look like? Well, I'm just going to take a look. I just clicked on a method over here, and you see that a method is actually of type method declaration, and the kind is method declaration. So that's quite easy. That's the kind. How do I check for the kind? So in order to get there, whoops, just messed up. Did I delete all my code? Ooh. Long live Control Z. Okay. So I can do switch parent dot kind. I can get the kind of that node, and I can say case method declaration. In case it's a method declaration, I want to do something. The reason I'm using a switch here is because if we have time, I will also add the case for a lambda expression and a local function, which also introduce parameters. But so let's just focus on method declaration. Now that we have the method declaration, how do I go from the method declaration to its parameters? Well, first of all, I need to cast this thing to more specific type. So again, typically, you take the syntax kind, double click, Control C. You will call that thing decal, or whatever you want to call it. Put that thing in between parentheses and put syntax at the end. That's the name of the corresponding type. So now I can convert this node, this parent, into a method declaration syntax. And once I have a method declaration syntax, I can go to the parameters on the parameter list that are associated with that. So I can get the parameter list over here. I can do some defense here to make sure that things are not null, if I really want to do that. But what you're going to see, well, let's not get into too much detail. What's really happening here is that when the user is typing code, the syntax trees don't get mutated. We get new syntax trees, and in certain cases, we'll have certain nodes in there which contain errors because the user is not done typing yet. So typically, you will see a lot of defensive code and those kind of things. And I've actually seen some custom analyzers that, have a null reference exception sitting somewhere in the output window because somebody didn't do a lot of checks. In this case, I'm just going to put one in here. And so now I can also go to the parameters over here for each var parameter in that parameter list. And I'm just going to yield return that parameter. So in a nutshell, what I've done here is I started from the place where I found a string. It's a string literal used in an argument position. That's a smoking gun for something that potentially could be substituted for name of. I'm now walking up the tree to the parent, the grandparent, the grand-grandparent until I find some method declaration. Method declarations can't be nested, so I won't find more parents here. I could actually break out of this whole loop if I would like to in this case. If you use local functions, they can be nested, and lambdas can be nested, so you want to sort of continue going. Ignoring those cases for now, I'm just yield returning all of the parameters, and then the caller to this thing is just going to check if any of those parameters, has an identifier tactical to the text inside the string literal. Okay, so that should be sufficient to actually bring up the light bulb if everything is going fine. So let's run that thing. And we'll have to be rather quick at the end in order to change, to build a code fix. But we'll see, how far we get here. So here's my try analyzer solution. I hit F5. I'm now actually debugging my analyzer. I could set breakpoints on the other side to sort of see where I messed up. Let's hope I didn't mess up anything. Again, writing to the component cache, like it's installing this thing, doing some updates of, all the plugins that I have in Visual Studio because I've just, really installed my own code into this Visual Studio instance. And let's see how this thing looks. Here we go. We have some light bulb and suppress name of fix. You know, there's something here. Oh, actually, you know what? You know, I didn't change, you know, all of the stuff over there, but you see name of fix over here actually. So my code is actually working. You see use name of here, but I didn't change everything in the resx file apparently. But you see the squiggle underneath this thing is just some stuff over here that's not completely right in the way it renders, but you see the squiggle underneath S. You don't see it under X over here because I didn't deal with, you know, looking for parameters in the context of a lambda expression. I could also put another case in that switch statement to actually look in lambda expressions as well, and then I would end up having a squiggle underneath here as well. Okay, so that's the first step. I now have, you know, the squiggle actually showing up over here, and you know what you see still is make uppercase. It's actually completely right, you know. It's just a little bit strange. It's because my code fix is still, you know, the code fix that comes by default, which wants to uppercase program here. Like, you know, it still has that code inside of it, but the top thing is actually correct. You see name of fix, that's my name, and that's my text over there. So the text you see in make uppercase comes from the code fix. So you see string literal s can be changed to a name of expression. Of course, it's not rendering the right thing, and that's where we actually switch gears to take a look at the code fix provider. Okay, so let's close this thing. And now go and look on the other side. So the first thing is the analysis. The second thing is the mitigation. So that's the thing that needs to suggest a change to the code. So what does a code fix provider look like? Well, first of all, let me get rid of a bunch of, you know, unused usings over here. I'm actually exercising exactly the same framework, exactly the same techniques over here. When I did control dot, it's running code that you could have written yourself as well. Okay. So the make uppercase came from here. I will do something like here, change to use name of. Okay, so that's what's gonna render over there, reducing the confusion. Just for, you know, fun and kicks, let's also, like, you know, make this one beautiful. And so now we have to change this piece of code. So this piece of code gets called back when the user hovers over the light bulb or clicks on the light bulb. Two cases. What's the first case? The first case is there is a code fix here. The user is interested in seeing how it would look like. Like, what's the change you're suggesting to do to my code? That can actually allow Visual Studio to render things in red and green to say, we're taking this out, we're putting this instead. The second time this thing actually gets called is when you commit that code change. When you actually click on the light bulb, you know, that change has to be persisted, of course. So there's multiple places. The same holds when you do fix all. Like, you know, you could sort of see one example, and then you do fix all, you get the dialog of all the changes across the whole solution or the whole project, and then you can actually invoke that, and then the change is really being made. Now, there's a bunch of stuff in here. Well, first of all, some comments that I will get rid of, so it will look a little lighter. But so where we're going to be parachuted in is the diagnostic, which is the light bulb that has the squiggle and the location in the code, will actually contain where, you know, we currently are. So this is actually the location of the diagnostic. And so one of the first things this thing does is it's going to go and start from that location trying to find the thing to replace. In this case, this thing is just walking up the tree to find, you know, the type that I want to change the name for. That's the example that comes in here by default. Now what I want to change instead is actually that literal expression. I actually want to change the string literal that's sitting in the argument position. I want to change that one to a name of. Okay, so that's the thing I want to fish out over here. So that's actually str, let's say. Okay, so that's the string literal I want to change. Next, there is something here that says register code fix. That's where Visual Studio says, well, this is not just an analysis that's complaining about things. This is an analysis that also has a mitigation, that has an action associated with it. So we have to create a code action. The title is that string that I've just changed a moment ago. And now I have to do either of two potential change implementations. One is I want to change the entire solution. That's what happened for changing the name of a type, because that type can be used in many files. People can refer to program, so when I change the casing of program, I have to touch the entire solution to change program to the different casing. In this case, this is a local change. When I look at a parameter, parameter doesn't leak out of the current document. So I want to create a change to a document. And so I get a cancellation token here. I will explain what that thing does in a moment. And so I want to be called here when the user clicks on the code fix. I want to use name of here. That's the name of the method I'm going to use. And I'm going to pass in that literal str that I want to change. Okay, so use name of is going to be a method, and we'll just generate it here using control dot because Visual Studio can infer the parameter types and the return type for me. And so now what do I get? Let's take a step back. I get a document. I get the literal expression syntax containing the string I want to replace. And I also have the cancellation token that I should observe to get out of there in case the user says forget about it. Like if we're doing a lot of changes, the user can click cancel in all sorts of ways. Or there could be other edits happening and Visual Studio says stop doing whatever you're doing. I'm going to implement this thing as async. Now there's not that much to know here except for one key thing. The key thing is that you can't go in here and do something like go to the document, go somewhere, and then use an assignment, change something. All of these things are immutable data structures. And the reason for immutability is, as I talked about in my performance talk, it allows those things to be shared across multiple threads. You have the UI thread, you have input happening, there's a whole bunch of stuff happening in Visual Studio. At the same time, we don't want to have concurrent mutations, we want to be able to reuse parts of trees. Immutable is actually a great way of building those kind of abstract syntax trees. So what I have to do instead is I have to create a new document. And that's why you're seeing a document being passed in, and you have to return a new document. In addition, that allows Visual Studio to say, here's the old document, I give it to this code fix. The code fix gives me a new document. Now I can just create a delta between the two. I can see what has changed. They took out this, they put in that. Let's render it. Okay, so I need to create a new document. Now how do I do that? Well, let's start at the bottom. Let's say old document equals document. Okay. And var new document equals old document. That's not a change, but I want to return the new document. I'm just going to be super verbose here. So you see that I have an old document, I want to do something, and then I get a new document. Now, how do I change a document? Well, the answer is that the new document will actually be the same as the old one, but I want to replace something in it. That's really saying clone this document with one exception. I want to clone everything to be exactly the same, but one thing needs to change. What's the thing I'm going to change? I'm going to change the syntax root of this thing. The syntax root is the top level of the tree. Now, recursively, we want to create a new syntax root, which is a whole new representation of the AST. How will I create a new syntax root? I will take the old root, do something to it using this with stuff. I will get a new syntax root and plug it in here. So I'm going to put new syntax root here, and var new syntax root equals old syntax root. Where do I get the old syntax root from? Let's take a look at the old document. So you see how I'm reasoning here. I need a new document, it needs a new syntax root. Where do I get the old document? Where do I get the old syntax root? So var old syntax root equals old document.get syntax root. Oh, you can get syntax roots in an async manner, no problem. You just call get syntax root async and you await that thing. So now I have the syntax root, the old one. Okay. Now in that syntax root I want to replace one node. I want to do something called replace node here. Replace node takes a tree, will search for a node, replace that node that I specify with another node. So I want to take the old node and put in the new node. What's the old node? Old node equals the one that was passed in here. That's what the user wrote. So this will be my string literal bar. Now I need to create a new one over here. Okay? So what's the new one gonna be? The new one is gonna be name of bar. Because I know that there is some bar in scope, I can just put name of bar over here. So my new node is gonna be, now I have to create a syntax tree. So how do you create a new syntax tree? I want to create something that looks like this. I want to create name of bar. How do I do that? Well, this looks like an invocation of a function with an identifier called name of, and it has an argument called bar. So how to do that? You go to the syntax factory, There's alternative ways, to get to this. You could also have a string, give it to something that will parse it and then end up with syntax. I'm just gonna use the syntax factory over here, which is the cleanest way. Now I'm gonna do a lot of syntax factory stuff. So what I'm gonna do instead here is I'm gonna using static from C# 6.0. So that will actually make it a little bit more bearable. So I don't have to do syntax factory.this, .that, .the other thing. I will just be able to use those things as global functions, if you will. So I want to create an invocation expression. And I want to invoke something called, invocation is something that has a left-hand side, parentheses, an argument list, and another parenthesis. So I want to invoke something. What do I want to invoke? I want to invoke something with a name, an identifier name that's called nameOf, and then I have to give it an argument list. So I'm going to give it an argument list over here. So far so good. And that argument list needs to contain, let's see what the IntelliSense wants, it actually wants a separated syntax list. Separated syntax lists are lists of things that are separated by something. In this case it would be commas, but we only have a single one. So there is actually a singleton separated list, which takes in a single node, which will be the single argument. What's going to be the single argument? Now I'm here. It's going to be bar. Okay, so this needs to contain an argument, because argument lists contain arguments. And the argument contains the expression that needs to be put in there. If I would want to call foo with 1 plus 2, I would now call the syntax factory for the plus operator, with the left-hand side being a literal for 1 and the right-hand side a literal of 2. In this case, it's actually bar. So this argument needs to be an identifier name. And the identifier name will be, what's the identifier name? Well, I have the old node, which is my string, which has a token, which has a value text. That's what the user put in the string literal. In double quotes, they put bar. So I'm now copying bar over here. And so now I'm actually translating bar in double quotes into name of bar. I'm then feeding it into the replace node function that says replace the old thing, the string literal, with the new node, which is invoking name of with bar, and then return a new document. So that's how I sort of change the document. You have to just, use those factories. Again, how do you actually figure out all of those factory things? Just write it somewhere. Just write name of bar, click on it with the syntax visualizer and start looking. Oh my God, this is 20 levels deep. I'll just take a piece of coffee or a piece of chocolate, and just blow through it, like one step at a time, like this, that, the other thing. It's just, it's monkey business, it's compiler stuff. Okay, so let's just hit F5. And now fingers crossed, I have 2 minutes left. We should see the light bulb, that worked before. Let's hope that it now also does something correct. Okay, so let's go here. It's loading my sample project, updating the component cache, a little bit of patience required here. By the way, you can just set breakpoints on the other side to edit and continue. It's just like any other application. Don't fear that you're attached to Visual Studio. Like, you can attach to anything, Windows people attach to the whole operating system. So here you go. Fingers crossed. Light bulbs come, please. Here's a light bulb. Okay, good. Click on the light bulb. Change to use nameOf. There is a preview. The preview looks promising. Click on it. Anticlimax, I wasn't zoomed correctly. Yeah. There's a nameOf on the other side of the screen. And so if I would want to make it work for this one as well, I would just add one more case, and you would actually be off to the races over there as well. So what we learned in a nutshell, you install the SDK, you create a new analyzer with CodeFix project, you get some default implementation that you can readily press F5 on, you can hit breakpoints, see how that thing works. You change the way you want to be called back. You say, I'm interested in syntax nodes. Maybe you're interested in symbols. Maybe you're interested in something else. There's a whole bunch of things you can register for. You analyze the tree. How do you do that? You learn about the shape of the tree by using the syntax visualizer. You pattern match effectively. You check a bunch of conditions. In some cases, those conditions will be more involved. you will use things like the semantic model to check like what's the meaning of that variable, what's the symbol, does it refer to this, does it refer to something else. So you just assess, can I make this change, is this the thing I'm looking for? Once you know that that's the case, you actually raise a diagnostic, light bulb comes up, you click on the light bulb, invokes a code fix provider, the code fix provider gets the old document or the old solution, you create a suggested new copy of that, it's immutable, so you have to do things like replace to get copies of that thing, you return that thing out, Visual Studio's happy, green lines, red lines, user says okay, I'm happy, and the user applauds, okay? So that's how it works. If you have any questions, I'll be around for a little bit longer, so please come and see me. With that, I thank you for being here. I also thank you for bearing with me for maybe 5 times, some people. And I hope to see you again some other time in the lowlands. Thank you.